Alright, homework for 2-2, linear equations. And so here's what we're up to. We're going to learn how to graph linear equations, and then if we have a graph, how to write that as an equation, so going both directions. So something we'll be able to do is solve a transportation problem, which we'll see in example 2. Alright, so a whole bunch of new vocabulary today, linear function and linear equation. Alright, so both of these things are straight lines. That's important to know on here. Get the pointer going. Right, so both of these things here are straight lines, and that's what we're going to be dealing with in this section. So anytime you see linear, you're thinking about straight lines. We'll talk about independent and dependent variables. Just a quick check on this one. Independent's going to be x and dependent's going to be a y variable. Okay, we're going to see that. Intercepts we're going to come to. We're going to have x-intercepts and y-intercepts here, and then we'll have standard form, slope, point slope form, and slope intercept form. Whole bunch of different equations. We'll get these later on. Alright, so we'll talk about all of these things. Alright, whole bunch of vocab. Here's our first one. A function whose graph is a line is a linear function. Alright, so we said that already, and we can write that line as an equation by getting y on one side and x's on the other. What makes this a linear equation is it's x to the first, all right? X to the first power. That's going to be a straight line. And so the solution is any xy combination, any relation, the word from 2-1, that makes that equation work out. All right, so for this straight line, all of these relations, here's a couple examples. If we plug in the x up here, let's try this one. 3 times 0 plus 2. Is that equal to 2, the y value? And so 2 equals 3 times 0 is 0. Is 2 equal to 2, 0 plus 2? It definitely is. All right? And so we've looked at this. Just mentioned this briefly on the last slide. Dependent variable is our y, right? Because the y depends on what we plug in for x. So our plug-in value is the independent value. The input is the independent variable. All right? All right, so let's graph an equation here. Y equals 2/3 x plus 3. So the solution's given there, right? So we have that. We can plot some points. I think we all remember how, well, at least we should, from Algebra 1, that we can also do slope-intercept. So 3 up here on our equation is our y-intercept, and then also our slope is 2/3. So if we remember rise over run, from this point we're going to rise 2, go up 2. We're going to run, go over 1, so over 1, up 2, and we'll end up right about here. And then we can connect those points, and we end up with the same line as we have over here. All right, so we can either make a t-table over here, or we can use our slope-intercept, either way to graph the line. So use one of those two methods and see if you can graph these 3 equations, A, B, and C. All right, so let's talk about some intercepts. So intercepts are where a line crosses the axis. If you're a y-intercept, you cross the y-axis, and an x-intercept, you cross the x-axis. All right, so intercept, I'll just get that down. Intercept, where you cross, not you, a line, where a line crosses an axis. Okay, and so y-intercept crosses the y-axis, x-intercept crosses the x-axis. All right, next thing up here is we can go introduce the standard equation of a line. And so the standard form of linear equation is ax plus by equals c. And so really what that's saying is get the x on the y and the y on one side and the c on the other. All right, we want a and b to not be 0. So here's an example. 5x plus 2y equals 7. Right? All the x's and y's on one side, the regular constants on the other. All right? If you get it in this form, it makes it really easy to find the intercepts, as we're going to find out in the next example. So if we have this equation, 3x plus 2y equals 120. All right? So this models the number of passengers who can sit in a train car. Right? X is the number of adults. Y is the kids. Let's graph the equation. All right, so it's nice to graph equations using intercepts because that's going to give us 2 points and we can connect them. So right here, these are the steps for doing that. We're going to plug 0 in for y. That leaves us with just 3x equals 120. If we divide by 3, we get x equals 40. So over here, we can make that dot. Right? If y is 0, x is 40. As a numbered pair, it would look like that, 40 comma 0. Do the same thing, plug 0 in for x. Right? That means the x's will go away completely, and we'll just have 2y equals 120, or y is 60. So when x was 0, y is 60. And then we can connect those 2 points and have a nice line. Right? So we have that there. All right, so let's talk about the domain and the range. The domain, what's the smallest x value you see? The smallest one I see is 0. It's less than x. And the biggest x value you can have is right here, is 40. All right, let's talk about the range. The range, we're going to go from 0, less than or equal to, y, less than or equal to 60. That's your highest y value. All right? See if you can figure that out for problem 2 on your understanding check. And I just like that picture right there. This is a real picture. This is actually what has to happen in Japan. There are too many people for the trains. Get in there. All right, let's talk about slope. If we remember, slope is rise over run, vertical change over horizontal change. And this is a review from Algebra 1. Here's this formula again. y2 minus y1 over x2 minus x1. Remember, you cannot divide by 0, so the denominator can't be 0. So here we go. Let's find the slope of 3 comma 2 to negative 9 comma 6. And so we'll put our y values in on top. 6 minus 2. You see them here. 6 minus 2. And it would not have mattered if you reversed them. If you went 2 minus 6, that's totally fine. As long as, if you notice for the x's, 6 and negative 9 match up. So we would have to have, if we went the other way, what matches up with 2? 3. We'd say 3 minus negative 9. We'll get the same answer here because negative 4 over 6, negative, what am I doing? Minus a negative is a plus. I can't do algebra. Negative 4 over 12 is going to be negative 1/3, which we get the same answer here. All right, so that's the way you do slope. Make sure you keep track of your negatives, unlike I did there, and see if you can get the correct slope for problem 3. All right, so once you have the slope, if you have a point, we can use our point slope form. Y minus y1 equals mx minus x1. For instance, if we have this point, just making up numbers, 5, 3 with a slope of 2, we would say y minus our y number equals m, our slope, x minus our x number. That'd be our answer. All right, this is called point slope because you used it if you have a point and a slope. So here's our example. If our slope is negative half, and we go through those points, y minus negative 1 equals negative 1/2, x minus 8, and so we've got y plus 2 equals negative half x plus 4. And then in the problem they said write it in standard form. So we're going to get all our x's and y's on one side. So move it over, y plus half x equals minus 2 minus 2. Did I not distribute right? Oh, this is a 1. Plus 1. Getting ahead of myself. So we'll have to minus 1, so we get 3 on this side. And you'll notice here, standard form, we do like to write the x before the y. So I'd rewrite this 1/2 x plus y equals 3 for our final answer in standard form. Try it for problem 4. All right, example 5. If I'm given 2 points and I want to do point slope, the first thing I need, because I have a point, in fact I have 2 points, I need the slope. So first thing we'll do, we'll find the slope. 5 minus negative 1 over 1 minus 4 equals 6 over negative 3 equals negative 2, and that's our m. All right, so once we have that, we're going to go ahead and plug that in. Now we could use either point 1 or point 2. I'm going to pick point 1 because there's no negatives in there, right? Let's choose the one without the negatives, just to make it easier. Nothing wrong with choosing the one with negatives, just got to be careful. So y minus 5 equals negative 2, x minus 1. And we'll figure this out here. And that's it actually, because they said write it in point slope form. And that is point slope form. Don't have to move it around at all. So we are done. See if you can do those steps for A, B, and C on problem 5. Okay, so now's the one that I think most of us probably remember the best from algebra, the slope-intercept form. Y equals mx plus b. M's the slope, b's the intercept. All right, so find the slope of 4x plus 3y equals 7. If we can move this around into slope-intercept, we can just grab the m and the b. So that means getting y all by itself. Minus 4x to both sides. So we get 3y equals negative 4x plus 7. Divide by 3. We get y equals negative 4/3 x plus 7/3. 7/3 is your y-intercept. Negative 4/3 is your slope. And that's what the problem was asking for. Find the slope. So we've got it. All right, so get y by itself and figure out the slope for A, B, and C. All right, so just a summary here. We have 3 new forms. Not new, you know these from algebra, but reviewing the forms. Point slope form, standard form, and slope intercept with an example of each one. I would definitely have these down in your notes. We use them a bunch. And then the last thing here we're going to add on here is what happens if we have horizontal, vertical, perpendicular, and parallel lines. So horizontal lines like this, if we're flat, the key here is that the slope is 0. And then y equals a constant. So something like y equals 5, y equals 10. Those are horizontal, flat lines. Okay? If we are undefined, we're going to have x equals a constant. So x equals 3 would be a vertical line like this. No y at all because the slope is undefined. It would fall off the mountain. All right, if we're perpendicular, the slope of the 2 lines are negative reciprocals of each other. So if the slope of this line is negative 1/3, the slope of the red line would be positive 3. One's a negative, one's a positive, one's a fraction, one's the reciprocal of that fraction. As opposed to parallel, where both of them have the same exact slope. Right? If that slope is 3, then that slope is 3. And they would never, ever touch each other. All right, so on this one, last example, let's write an equation of a perpendicular line here. So we can see here, we've got the steps. We have our original equation, y equals 3/4 x. All right, so now we want the equation that goes through 0, 4, right? So let's figure out what's the reciprocal of our slope. The flip of 3/4 is going to be negative 3/4. So then we can plug it straight into our slope-intercept here. Not a huge fan of doing it this way like the book does. I like doing it point slope. I think it's faster because we can go y minus, plug in our 4, equals our new m, negative 4/3, x minus our x value, So now we have y minus 4 equals 4/3 x. And then we add the 4. And so there is our equation. All right? Same thing we got over here. Can do the same thing for b with 6 comma 1. We're going to still use negative 4/3. Right? So they use point or slope intercept here. They plugged in 1 for y and 6 for x, and distribute that. You get b is 9, and so rewrite it here. Y equals negative 4/3 x plus 9. All right. This is probably the hardest thing in this chapter. Let's see if you can do it. For problem 7, take a look at those 3 points. Any questions? We'll go over all of these in class, and you can also reach me at lunch or email me if you have questions. Good luck.